Hello and welcome to my second combinational circuit video. This one's going to be all about universal gates and combinational analysis in Logisim. Um, so, briefly defining what a universal gate is. A universal gate is just it's a gate that can express all forms of logic. So, for example, there's the NAND gate, and typically our sort of primary gates are and, or, and not. However, with a NAND gate, we can express every single combination of logic, or we can basically produce any output given any number of inputs just with one single gate. Like gate class, not just one gate, but class of gate, which is the NAND gate. It can be used for everything. You can make an entire PC out of NAND gates. So yeah, that's what it means to be a universal gate. And so in this task, given the topic of universal gates, we're given a Boolean equation, and we need to convert that Boolean equation into a circuit, and then that circuit into an all NAND circuit. And so we are given the, I'll just bring it up on the screen. We're given this equation here. It's A or B prime and A and C prime primed, or B or C quantity primed. And so I took that equation and I made it in Logisim. So that first logical expression was A or B or B prime. So it's not quantity prime, just A or and then B prime. So that is expressed here. It is A or B prime, and A and C prime primed. So it's and A or A and C. So it's A and C, and that's C prime, and then the whole thing is primed, and then they're both put into this AND gate. And then lastly we have, and then that whole thing is ORed with B or C prime. So it's B and C prime ORed with that entire previous expression, and that'll give us our Q. Let's see here. Okay, yep. So, and then the next step was to turn that into an all NAND gate. So I put over our unsimplified equation here. I turned all of that into NAND gates. And so you can express an OR gate through a NAND gate with two NOT gates at the front as inputs. And then for an AND gate, you can do a NAND gate and then just not the output. And so with that, I just turned everything into NAND gates. And as was expressed in the video, we don't need to get rid of these NOT gates because, I mean, I could turn them into NAND gates, but it just makes everything like unreasonably complex for no reason. And so we were told that it's fine to just leave those NAND gates. It doesn't mean anything different. And so I turned that into the NAND gates, and then to simplify it, all you do is get rid of the double NOT gates. So ultimately I came up with this circuit here. And yeah, then I just put that into this individual file so that in the next step I can run combinational analysis. And so we're instructed to use combinational analysis to compare these two gates to make sure that they're equationally equivalent. And so we can go ahead and do that. So typically you would go here, you go Window, then Combinational Analysis. But in order to get equations generated by Logisim, what we can do is we can go into Project and then Analyze Circuit. And so it'll compute a truth table and an expression for us. And so here's our table that it just computed it for this unsimplified equation. So this is the original equation. And this is the expression that it came up with. B prime or C and B prime or A and C, which is given here by this K map, and then ultimately computed down here, and then it'll tell us here. So remember that was B prime or A and C. And so that was the equation that it gave us for that one, B prime or A and C. And then we can go to our simplified NAND gate, and we can run the same circuit analysis and compare our answers. So I labeled them B3, B, A3, B, B3, and C3. Doesn't matter, just consider them B, A, and C. They're all the same, it's just variable names. And that one ends up being the same. It's B prime or A and C. So by using the analyze circuit function, we can compare the two equations that it gave us, which are exactly the same. And we can actually convert those equations into a Logic Sim will generate this for us, this gate for, or this circuit for us. But we can do that now, just to really prove that these are equivalent. So we can do analyze circuit. We have this expression here. We can we can build a circuit, and we can name it combinational analysis. Combinational underscore analysis. We call it 1. So it just made it a new. Oh. It just made this right now. This is combinational analysis 1. We can even delete this. It's gonna let me. Okay, so that's the first one. That was generated by the unsimplified circuit. And then we can go into the all NAND simplified circuit, and we can do the exact same thing. We can build the circuit, call it combinational underscore analysis 2. And we can compare these two. So we can just kind of jump back and forth. They are literally the exact same, except for variable names, which doesn't matter. So there we go. We've proven that they are exactly the same. And this one is all NAND gates. This one is a basic AND/OR structure. All right. So I believe that is all. Yeah, cool. That's all for this video. Thank you for watching, and thanks for checking out the website. We'll see you next time. Bye-bye.